minus infinity to infinity of c of n e to the j n omega naught t, right? And c of n is defined as an integral. C of n is defined as 1 over t, the integral really from 0 to t, or over any one period, of x of t e to the minus j n omega naught t dt. Now that's the relationship. Now, if you want to turn it into a series of sines and cosines, what can we do with this e to the minus j n omega naught t? Think. What am I going to do to that to turn it into sines and cosines? What's the name? Euler's, right? E-U-L, right? And what does it become? People? Cosine of the argument, right? So it's cosine, right? Of n omega naught t, right? Now there's a minus sign here, so it becomes minus j sine of n omega naught t. Are you with me? Class? Now you'll notice that I can say that series itself, or this I should say, could replace that, right? And once, let me do it here. Sorry, let me do it up there. I'll put a plus here, make it plus. I want to do it, I know he used the minus there to put it in there to get he gets a of n and b of it, but just let me show you something. If I do it this way and put it up here for the x of t, then you'll see it exact. I can see that x of t here can be rendered as the summation from n equals minus infinity to infinity. Now I'm going to go ahead and leave c of n there. And I know c of n has a real and imaginary part, doesn't it? In general? C of n. It's going to be times, and now it's going to be times cosine of n omega naught t plus j sine of n omega naught t. All right? Now, if you look at this, c of n times cosine n omega naught t would be like a of n times cosine of n omega naught t in the sine cosine series in the book. Have you looked at this yet? You asked me the question, you know what I'm talking about. How many know what I'm talking about? In general, there's a sine cosine series that is used where the coefficient here is a of n. You see it as c of n, right? Are you with me? Now, the other thing is this. The summation is not from minus infinity to infinity, but from 0 to infinity. So we're going to show you a trick on that one. But c of n times j would be b of n times sine of n omega naught t. Now here's the real bottom line of this. I'm going to record it. The mathematics departments, where I'm from, where you're from, have a thing for this trigonometric series. Don't know why. As engineers, where we're applied, we want to use something that can analyze or synthesize things. We're not worried about the beauty of the formula. We almost always use this. And I'm going to turn it into the cosine series in a second. But this is the go-to, so that answers your question, hopefully. C of n. Now, I said specifically only calculate C of n for those, right? Remember in the homework, I didn't care about a of n and b of n, did I? That's the only thing I cared about. Out of curiosity, just let me. How many actually took a look at this stuff and tried it? All right? If you did the derivative method, it was straightforward. Very easy. If you did integration by parts, you'd probably beat your head on the wall. Because it takes a while, a long while. Did y'all notice this? Anybody notice this? God help you. I mean, if you try to do that for a lot of these functions, you're going to be pulling your hair out. Because sometimes it's two integration by parts things. It's a real pain. That's the reason I'm such a, I always point to the derivative method being so much easier. Before I show you a trick here, I'm going to turn that exponential Fourier series that I wrote there, I'm going to put back e to the j and omega naught t, and I'm going to turn it into just a cosine series summed from 1 to infinity with a magnitude of c of n. I'm going to show you a trick, and add the phase angle inside the cosine. You're going to like this because that's exactly what you're used to dealing with. when you had Dr. Irwin's course or whoever taught you circuits, didn't you have 10 cosine of like 377t plus 30 degrees as the input to a system, right? You didn't analyze it with differential equations. You said that was a phasor. It was 10 at an angle of 30 degrees, right? So if we can turn this into something where I have magnitude of C of n, or some coefficient, cosine of n omega naught t plus a phase angle, I've got a phasor input at each frequency. And I can easily get the output of the system. I'll take you through it. That's the real reason this is so powerful. Okay, now, before I say anything more, did you have a question about the homework, a solution, or something like that? Anybody? You got one? Say again?
510.
510. What time's our game Saturday?
I think it's 6:30.
6. Good. You look cool. Maybe. All right, this is 510. Can you just tell me what it is briefly? No? Can anybody tell me what it is?
It's
Yeah.
complicated.
What's that? Is it a square wave? On my book's down there.
Kind of like a trapezoid almost.
All right, help me out here. We can make this happen.
It's coming
This
at
is
an
T,
angle.
and this is X. Say
It
again?
goes from -6 to +6.
Where does it start? At 0, what's its value? T.
A.
A.
A equals 20.
This is 20? So it's 20. Keep going. What does it do now?
It goes out to 1, remaining at
What do you say? That's 20. You can't go
On
on.
the T value, it goes out to 1,
Oh,
remaining
okay.
20.
Then?
Between there and 3, it goes to -A.
It passes through 2 at the axis.
Yeah, and that means it's got a nice, easy slope to render and figure out. So that's 2. This is an exact, is that right? And then what does it do?
3 to 5, it remains at -A.
Good. All right.
Then from 5 to 7, it goes back up to A.
And it repeats itself, right?
And you have, at 7, it is at A. And
Oh.
then from 7 to 8, it goes,
It does this. This is a poor drawing, but I think you understand what's going on here. And then it repeats.
7 to 8, it goes to A. So the whole thing starts at -1 if you want to start at the A
This is where
value.
it starts at -1,
Yes.
and is it repeated over, well,
Oh, the period is 8 seconds.
is this about a fair render? All right, so from -1 here, all the way, if you look at this, goes up, down, over, up, and here it restarts the whole thing again, right? So it's got a period of 8. This is a fairly straightforward, it's an easy one now. If t equals 8 seconds, right? Now, we're going to end up taking 2 derivatives here to get C of n. I hope this answers your question. What I wish I did is collapse that whole thing, but I didn't, unfortunately. Now, can you all see when you take a derivative of this? Just listen to me. I'm going to put the derivative over here. This is going to be x prime of t. And let me label this. 1, 2, 3, 4, 5, 6, 7, 8, -1, -2. I'm going to take a derivative, and I want you to listen to me. This, at -2, it's flat back here, right? You agree with me, class? Now take a look at the first derivative of this. The derivative is the slope of the line, right? So from -2, you see the derivative of this part with respect to t is 0. At -2, it's got a positive slope, right? It goes from -20 to +20, doesn't it?
Hold up.
Say again?
If the slope going down, it takes 2 to get to 0, you're only moving back 1, so it'd be at 0 on the graph, right? Or did I
From
miss a
here to
step?
here, right?
Right, so it should go down 2 till it's at the
From here
negative.
to here, it's an increase, right?
Right, but it's got a slope of 2 to 1.
Well,
Or,
it's got a
well-
slope of what? Difference of 40, the rise, times 2. is it? It goes from minus 20 to plus 20, doesn't it?
Right.
Over a range of 2 seconds, is that right?
Right, but you're going from 1 to 2, so that's only 1 second. So you go down to 20 where you'd be on the 0
I'm
axis.
sorry, is this is from minus 3, is it?
Okay.
I apologize, sorry about that. Thank
You're
you.
good.
From minus 3, my bad. All right, so from here, thank you. From here to here, the actual difference in time is 2 seconds, and the difference in actually, the value of x of t is 40. Do you agree? So I have 40 over 2 or 20, right? That means that it's positive. So actually, minus 3, thank you. From minus 3 to minus 1, I have this. And the slope, I mean, this is going to have a weight of 20, right? Correct, class? All right, keep on this. Now it stays 0 until I hit 1 second. Am I right there? Right? I mean, there is no slope. The slope of this line is 0. Correct, class? For the derivative. Now, from 1 to 3, it has the same magnitude slope, only negative. Doesn't it, class? So now from 1 to 3, I have this. And that's minus 20, correct? Agreed? Now, from here to here, it's 0 again, correct? And that's to 5, right? And then at 5, what happens? That's a lousy way to draw it. Follow me, look in your book. Do you all see this, class? Is that right at 5? Now it goes back up to what? Now it's going, is it 5 or 6? People tell me.
5.
It stays there till 7? All right. If that's true, if you look at this, the period on this thing, I did something wrong with the period. It starts at, let's see, no, it's right, 8. So, yeah, minus 3 to 5, that's right. The period is 8, right? All right, now that's the first derivative, correct? And again, the first derivative is equal to the summation here, right, of jn omega naught, right, times c of n e to the jn omega naught t from n equals minus infinity to infinity. And it's also equal to the summation from c of n prime e to the jn omega naught t, n equals minus infinity to infinity. And that means c of n prime is actually equal to jn omega naught times c of n. We did this last time. Do you all remember this, class? Commission. Yeah.
What's it say on the side? C and prime equals?
This is c of n prime, that's this, is equal to this, jn omega naught c of n. It's the same thing. The reason I'm putting the c of n prime in here is I can calculate that from the integral, right? C of n prime is 1 over t times x prime of t, the integration of e to the minus jn omega naught t dt, right? Now, we don't have delta functions yet, do we? That's what we're going for, aren't we, class? Every time the derivative method, you use it, you want to get delta functions. Are you with me? Now we take another derivative, and I think you'll see this. So here, the next derivative, this is going to be x double prime of t, and minus 3, minus 2, minus 1, that's 0, 1, 2, 3, 4, 5. And this is going to be my x double prime of t. Now take a look at that for a second. This, I'm telling you, this should be fairly obvious. I'm just trying to have an actual break there. When you take a derivative of x prime, what do you get? Where's the first discontinuity that you see on the board? At minus 3, right? It goes from where? 0 to 20, right? And that is a delta function, right? And it's positive. So I'm just going to draw it like a spike with a weight of 20. We know it occurs at minus 3. Agree, class? Where's the next one? It's obvious.
Negative 1.
Minus 1, where does it go from? 20 to 0, which is? Minus 20. Very good. Minus 1, correct? Keep going. Keep going. Next one,
One.
which is negative, right? Not positive, negative 20. So I got another one here. Minus 20. Keep going, finally.
A positive at 3.
At 3 it goes up to
20.
positive 20, right? And that's the delta function representation, right? Now we've got all delta functions, correct, class? So that being the case, do you mind if I erase this so I can use this board? This is, we know what it looks like. You've got it in your book. But now look at this. I'm glad I got to do one of these. This one is actually one that's pretty easy to do because you just have to get one function with derivatives. Now when you look at this, x prime of t, right here, that's rendered as what? Double prime of t is equal to the summation n equals minus infinity to infinity, right? Of C of n, I'm going to show you this. You're going to get used to not even having to do this. You see how I take another derivative of this, that brings out another j and omega naught. Right, everybody? So now I get C of n times j and omega naught squared times e to the j n omega naught t, right? Now that means this right here is my Cn double prime. Is it not, class? Y'all see that? And that means I'm going to calculate that using the definition of Cn double prime. I could replace that by Cn double prime, right? And that means my Cn double prime is 1 over the period, this is the formal definition, times the integral, and really it's over a period, from any point epsilon to epsilon plus the period t, of x double prime of t, e to the minus j n omega naught t dt. That's the formal definition, right? I put it there for a reason. We know the period is 8. I'm going to leave it as t for now, right? And we have to integrate this over one period. And we know when we have delta functions in here, what do? When you integrate a delta function here, delta t, for instance, times e to the minus j n omega naught t dt, it shifts out the value of whatever it's multiplying at the point when the delta function turns on, right? You realize there's a weight of 20 on that delta function, right? So here's how I'm going to write this. I'm going to say this is going to be 20. I know it's going to have a weight of 20. Over the period, that's 8. And now we go about evaluating this. Here's how I'm going to do this. I'm going to start from right here, and I add 8 to it, and that means I come to about right here, right? Somewhere up there. In other words, I'm going to start, I know a period's 8 seconds, I'm just going to move it down until I capture all of this. I don't want to start on a delta function. All right, class? How many see this right here? I want my integration to start at a point where it's 0, there's nothing. And I want it to stop at 0. So I'm moving that range of integration. It's got to be a period long, but over that. What do you see happening here? This one turns on at t equals what? Minus 3, correct? So when t is minus 3, what do I get here? E to the minus j n omega naught minus 3, or plus, correct, class? Isn't that right? So I get e to the j n omega naught times 3. The reason is because t was minus 3, not 3. Agreed? Are you seeing it back there? What's the next one? Oops. Go ahead, help me out, guys. You see what I'm doing? I'm integrating x double prime. That was the first one, right?
So
Next one, minus 1, right? What's the value? It's actually minus that, isn't it? Because I factored the 20 out. So now it's at minus 1, so it's going to be minus e to the plus j and omega naught times 1. Just leave it like that. Do you agree with me? What's the next one?
E to the negative
Where's
j.
that? Right here, right? At t equal 1, right? So then it becomes minus e to the minus j n omega naught, right, times 1. Correct, class?
Why are we subtracting those terms and not adding them?
Because these are negative right here.
Oh, yeah, sorry.
I factored out the 20 because I didn't want to keep on writing it over and over again. The weight's 20 on that.
Yeah.
Agreed? Finally, what's the last one? 3, right? Positive, I mean, P is positive 3. So then I get a plus e to the what? Minus j n omega naught times 3. Correct, class? And that's my C of n double prime, without doing any integrations to speak of, just noticing what the value is of the adjacent function to the delta. Correct, class? Now, yeah,
So, the 20 on the top, if you didn't factor that out, all of those would just have a 20 in front of E.
that's right. That's that simple. Now, if you look at this for a second, I'm going to ask this. Can you see a way I could represent that stuff in there with maybe a function that we know? Just take a look at this for 1 second. Always think about Euler's. Y'all see that this, right here, and this sure look like a cosine, don't they? So I know that what? I'll put it here. Cosine of theta looks like e to the j theta plus e to the minus j theta over 2, doesn't it? That's called Euler's, right? Now, that means I can multiply by 2. And now I have e to the j theta minus e to the minus j theta is 2 cosine times whatever that theta represents. Y'all see that theta represents 3 n omega naught? And there's a plus, this is plus, that's plus, only has a negative exponential in it, right? So this is really can be replaced by 2 times cosine of this argument. How many see this? Extremely obvious and extremely simple. Now what about this one? Factor out the minus sign. Isn't this e to the j theta minus e to the minus j theta? Isn't that exactly a cosine? There's a minus sign in factor out. Do you all agree with that? So now I can say really what I have here is 20, and I'm going to put the 2 out in front, over 8. And then what I have is this one is cosine, I don't know how they do it in the book, of 3n omega naught, right, minus cosine of n omega naught. And that's the value of C of n. We didn't do C0, but I want to just focus on this. Now, I'm putting it this way because I understand it. Now, if you want to, you can go ahead and substitute omega naught as 2 pi over 8. Then this can be 2 pi over 8, isn't it, class? If you want. Omega naught is 2 pi over the period, right? The period is 8. You don't have to.
Why is it C of n and not C of n double prime?
I'm sorry, C of n. Lack of sleep, kid. You're right, that's C of n double prime. I apologize. How do I get C of n out of it? Might as well ask you. You're right on top of it.
Do you integrate it?
Class?
You divide
By j n omega naught squared, because we took 2 derivatives, agree? So if we take this and divide by j n omega naught squared, now we get C of n. So if I divide this by j n omega naught squared, now I get C of n. I want to make one comment here. J squared is minus 1, so I would reverse the order of these things. The omega naught is 2 pi over 8. If you want to, it would be what? Pi over 4. You could go ahead and substitute it in there and square it. But ultimately, this has all the essential information in there for C of n. Did that answer, I hope your question? All right, now, you see how much easier that is than the crazy integrations that they do in the book. It's so much easier, in my opinion. And if you do this, do problems with this, you're going to see it's lifesaver. Did they give the answer for C of n in terms of 2 cosines, or how did they do it? Do you know? Anybody? Did you take a look at that one? Josh? You know?
The answers were really different from what we're looking for. They pretty much made graphs out of it, and
Forget that. This is what you've got. That's how it is. Now, you can go ahead and put it in MATLAB and get the values and stuff like that, but that's the essence. Understand? Yeah.
Would you want us to try and simplify it down to like the cosine or basically the sync function for
No,
cosine?
you're not going to get a sync out of there, is it? Those are cosines.
The cosine version.
There is not a cosine version of a sync. all right? You ain't gonna, I mean, I don't know what they got, but you're not gonna get anything out of here. Now, we didn't do one thing, C0 we still have to get, and that goes from the original waveform, all right? When you take a look at the original waveform, there's one unique quality, notice I didn't represent it right. What do you notice about the area? If you integrated x of t over a period, what do you notice? It's 0. Do you all see that? I just look at that and I can tell. That means C0, 0. End of argument. Agreed, class? So that's your C of n. I don't know what they have. Out of curiosity, what would it be for, oh boy, I'm going to kill myself with myself. If I, you know, you could easily put this into a computer and get each value, couldn't you, class? You could just, for n equals 1 to say 10, here's the values of C of n. Magnitude and angle, no problem at all. You really wouldn't want to do that yet. I'm going to show you the next thing that's interesting. Very interesting. If you have another homework problem for some reason, you have a burning issue with anything otherwise. Really, the derivative method is the savior. It will cut through all those crazy integrations that they have, especially with the triangle waves. They'll drive you nuts.
Do a triangle wave problem?
There's a lot of them, right? But triangles, if it's just a jagged, like a sawtooth wave, that's perfect. First derivative, you get a square wave like this. Second derivative, you get spikes. That means 2 derivatives, you got impulses. After that, you can calculate the C of n double prime for that and just divide by Jn omega naught squared, and voila. It's easy. If you do several of these, you'll become very familiar. Did you do these? And you? All right. I mean, you see how much easier it is with that, the method I'm showing you? I wish the book would do it, but this book doesn't. When I do electromagnetic compatibility and radar, I always use this method. Yes, sir?
Honestly, whenever I looked in the book, like, it didn't help me out, but whenever you did this, I understand a lot more.
Well, the book is doing the integration to get C of n, which is absurd. You're wasting an enormous amount of time, in my opinion. Now, somebody in the math department might see this, and I'll get sued, but it's the truth. Engineers want to get at the right answer with the shortest number of steps and the least misery. Don't quote me on that one.
Aren't you on video?
I am, but usually nobody watches these things. I hope. I will tell you one thing, there are professors out there at MIT and stuff, and they have free coursework, and I mean, they get gajillions of questions sent to them by email. If they respond to 1 out of 5, I'd be amazed. They used to post the question and answer. But, you know, you get all sorts of crazy people. All right. If we don't have another question, here's what I'm going to show you now. I'm going to take that exponential series and I'm going to turn it into a single-sided cosine series. I want you to write this down. It's not in the book. It's very important. I'll try to give you supplemental material on this. So if I have x of t equal to the summation of C of n times e to the j n omega naught t from n equals minus infinity to infinity, I'm going to break it up to a series that it goes from minus infinity to minus 1, plus C0, and a series that goes from 1 to infinity. So I'm going to break this into 3 chunks for a reason. So I'm going to say it is C0, then it's plus the summation from n equals minus infinity to minus 1 of C of n e to the j n omega naught t plus the summation from n equals 1 to infinity of C of n e to the j n omega naught t. So I broke it up, the sum from minus infinity to minus 1 there, from 1 to infinity there. Got me? Pretty straight, right? You're wondering why? Because I'm going to turn this into a cosine series eventually. You all with me so far? All right. Now, think about this for a second, this one. What if I let n be positive infinity to positive 1? What would I have to change? The sign here, wouldn't that, class? And the sign on n here. So this would be c of minus n. And this would be minus j n omega naught t. And And then I can make that plus and plus. Couldn't I, class? Are you agreeing with me? You all see that? I just changed, if I'm going from minus infinity to infinity, where n goes, why not make n go from 1 to infinity and just change the sign on the exponential from a plus to a minus? Agreed? Now after that, the next thing I got to talk to you about is c of minus n and c of n. Don't write this down, just listen to me. If I have c of n here, I know it's 1 over the period, the integral, or can be represented from 0 to t of x of t e to the minus j n omega naught t dt. Do you agree with that? Isn't that the fundamental definition, right? Keep watching. And that means this has both a magnitude of c of n and it has an angle, e to the j angle of c of n. Don't write it down, just listen. Agree? Just think about what I've done. Do you all agree with that? That's defining c of n as I've done before, right? Now, what happens if I have c of minus n? This becomes plus, does it? That's the only phase operation in the x of t is strict real, isn't it, class? What happens over here? Well, then you would take the conjugate of this. This would be minus the angle of c of n. That is the angle. Understand? How many see this right? Or minus, do it this way, minus j angle of c of n. That's the easiest way. Anybody want to take a guess why I did that? I think you know. You're not going to say anything. And I think you know, but you won't say anything. Jeff? I'll throw it to you. What do I? Yes.
Does the cosine
Yes.
of omega?
There's that miracle word, cosine. Yes. Because now I can clearly see here, I can replace this right here. That's c of n. I'm going to do it in the next step. I can say this is c0 plus the summation, and now n equals 1 to infinity is the summation on both of these. Now look, this right here is what? It's the conjugate, or it's c of minus n, isn't it? So I can say this is equal to, and I'll just put magnitude of c of n here, or c of minus n, and it's e to the minus j angle of c of n times e to the minus j n omega naught t. It's that, plus, then it would be magnitude of c of n here, e to the j angle of c of n, times e to the plus j n omega naught t. Now, I put it there for a reason this way, so you can see I just replaced the terms above it based on that for c of n. Understand, class? Now, do you see my next step? I have e to the j angle, e to the minus j. I'm going to combine those. Follow me? And when I combine them, I'll slow down Megan in a second, but let me just get this down. This is going to be c0 plus the summation now from n equals 1 to infinity of, I could factor out the magnitude of c of n here. And now when I combine these, I have e to the minus j n omega naught t plus the phase angle of c of n. And then it's going to be plus e to the j n omega naught t plus the phase angle of c of n. With me? He does something like this in the book. He doesn't go through the steps. Do you see it in the back, guys? You guys see it? All right. And this is like a freebie. What do I do next? What does this surely look like? It looks like 2 cosine times this as the argument, doesn't it, class? So then I can rewrite this as simply c0 here plus the summation of n equals 1 to infinity, and now it gets 2 times the magnitude of c of n times the cosine of n omega naught t plus the phase angle of c of n. And I'll tell you right now, this is the answer for x of t. That C of n is still the C of n that was used up there. But now I have a series that's called single-sided because it starts as n equals plus 1 to infinity. And not only that, I have the most valuable piece of information I can get. This looks like a magnitude multiplying the cosine, where the frequency of that cosine is n omega naught, and the phase angle of C of n. Agree? Now I can say each one of those can be represented as a phasor. I'm out of time now, but just listen, because you got to listen. What I can do is take this and just say it's 2 times magnitude of C of n, right? At the angle C of n, operating at n omega naught. And I can stick that term by term into every filter and get the output. I'll do that on Monday, all right? But this is extremely powerful. Can you all appreciate this, what I'm doing? Now you don't have to write differential equations to solve this crap. You can say, I can go ahead and replace the inductance of an inductor as Jn omega naught L, and the inductance or the reactance of a capacitor as 1 over Jn omega naught C, and then solve at each frequency, n omega naught, for the transfer function, multiply that transfer function times that input in the phasor domain, and then bring it back to the time domain. You're going to see this, and it's really powerful. All right? All right, you want your quiz?